Imagine uploading 10 million family photos to the cloud. Every birthday, every vacation, every milestone. Now imagine a hard drive fails. Would you sleep at night? AWS S3 promises something extraordinary. 11 nines of durability, 99.999999999%. Store 10 million files, and you might lose just one every 10 million years. How AWS S3 achieves 11 nines. The complete engineering breakdown of the most durable storage system ever built. Here is our roadmap. We will unpack what 11 nines actually means, then dive into Erasure coding, multi-AZ architecture, data integrity checks, self-healing, the ShardStore engine, the durability math, and user-side protection layers. Let's begin. Let's put 11 nines into perspective. 99% durability means losing one file in 100 every year. At 3 nines, 1 in 1,000. But at 11 nines, one object lost out of 100 billion per year. Crucial distinction. Durability is not availability. Durability asks, will my data be lost? Availability asks, can I access it right now? S3 offers 11 nines durability, but 4 nines availability. Your data is safe, but the service might briefly be unreachable. The scale is staggering. S3 stores over 400 trillion objects. It handles 150 million requests per second across tens of millions of drives. At this scale, disks fail constantly, yet your data survives. Think of S3 like a magical library. Each book is split into fragments, scattered across buildings in different cities. Lose an entire building, and the book still survives. How does S3 protect your data? The naive approach is replication. Make 3 copies. But storing 3 copies of every object is expensive. 1 petabyte becomes 3 petabytes. At S3 scale, hundreds of exabytes. That's billions of dollars in wasted storage. There's a smarter way. Erasure coding. Think of it like a magic math trick. Imagine writing a secret message on 5 cards. Then you create 4 extra cards using a special formula. You have 9 cards total. The magic? You can reconstruct the original message from any 5 of those 9. Lose up to 4 cards. Doesn't matter. The math recovers everything. S3 uses a 5+4 erasure coding scheme. Your object is split into 5 data shards. 4 parity shards are computed using Reed-Solomon math. These 9 shards are distributed across storage nodes in 3 availability zones, 3 shards per zone. Any 5 of 9 can reconstruct your data. The efficiency is remarkable. 3-way replication costs 200% storage overhead. Erasure coding achieves better durability with only 80% overhead. Same protection, nearly half the cost. At S3 scale, this saves billions annually. Let's zoom into the infrastructure. An availability zone is a cluster of data centers with independent power, cooling, and networking. They sit miles apart, but within 100 kilometers of each other. Each zone is designed so that a fire, flood, or power failure in one cannot affect another. S3 distributes your 9 shards, 5 data plus 4 parity, evenly across 3 zones. 3 shards per zone. If an entire availability zone goes offline, a massive power outage, you still have 6 shards across the remaining 2 zones. You only need 5 to reconstruct. Your data is fully recoverable, but it goes deeper than zone-level protection. Within each zone, shards are placed on different racks, different servers, and different drives. S3's placement algorithm ensures no 2 shards of the same object share too much infrastructure. Even if a full rack loses power or a server catches fire, the blast radius is contained to 1 shard per object. Durability isn't just about redundancy. Data can silently corrupt on disk, a phenomenon called bit rot. A cosmic ray flips a bit. A drive's firmware has a bug. The data changes without anyone noticing. To fight this, S3 checksums everything. Every object gets a mathematical fingerprint when it enters the system. When you upload an object, your SDK computes a CRC, a cyclic redundancy check. S3 independently computes its own checksum server-side. If they don't match, the upload is rejected. No silent corruption enters the system. S3 supports CRC32C, CRC64, and SHA-256, with CRC64 as the new default. The real magic happens after storage. S3 continuously re-verifies checksums on stored data, scanning every shard across every drive. If a checksum fails, S3 knows that shard is corrupt and triggers automatic repair before you ever notice. Self-healing is the heartbeat of S3's durability. Think of it like a hospital that runs diagnostics on every patient every hour, even while they sleep. S3 continuously scans its storage fleet, every drive, every shard, every checksum. When it detects a problem, repair begins automatically. When a shard is lost, S3 reads the surviving shards. It only needs 5 of 9. It recomputes the missing shard using erasure coding math and writes the fresh copy to a healthy drive. Redundancy is fully restored. No human intervention required. Speed matters here. The window between losing a shard and repairing it is the danger zone. If too many shards fail before repair completes, data is lost. S3 repairs shards within hours, not days, keeping the probability of overlapping failures astronomically low. Under the hood, each storage node runs ShardStore, a custom key-value engine written in 40,000 lines of Rust. It won Best Paper at the SOSP Systems Conference. ShardStore uses a log-structured merge tree with shard data stored outside the tree to minimize write amplification on SSDs. Data placement uses shuffle sharding. Think of dealing cards. Instead of putting all your eggs in one basket, each object shards are assigned to a random subset of storage nodes. A single node failure only affects the tiny fraction of objects that happen to have a shard on that node. The blast radius is minimal. For load balancing, S3 uses the power of 2 random choices. When placing a new shard, the system picks 2 candidate drives at random and selects whichever has lower utilization. This simple rule produces exponentially better load distribution than pure random placement, keeping all drives evenly utilized. Let's do the math. A typical drive has an annual failure rate of about 0.5%, 1 in 200. If a drive fails, S3 repairs the shard in roughly 8 hours. The probability of a single shard being unavailable at any random moment is about 0.00005. Now apply the binomial distribution. With 9 shards and 4 parity, data loss requires 5 or more simultaneous failures. The probability of 1 shard failing is tiny. 5 failing at the same time. It's like flipping a coin and getting heads 50 times in a row. When you run the calculation, the probability of losing an object in any given year is about 1 in 100 billion. That's 11 nines. Not a marketing number. It's a mathematical consequence of erasure coding, fast repair, and independent failure domains. S3 handles hardware-level durability. But what about accidental deletion? The number 1 cause of real-world data loss. Versioning is your first defense. When enabled, every overwrite or delete creates a new version. Deleted objects get a delete marker. You can always restore any previous version. For the truly paranoid, MFA delete requires a 6-digit code from your authentication device before permanently deleting any version. Only the root account can enable it. Even a compromised admin cannot destroy your data. Finally, cross-region replication copies objects to a bucket in another AWS region entirely. Even if a full region suffers a catastrophe, your data exists independently in another geography. Let's build the mental model. Your object enters S3. Erasure coding splits it into 9 shards, 5 data for parity. These shards scatter across 3 availability zones on independent drives. Checksums guard against silent corruption. Background scanners detect failures and repair automatically. ShardStore manages the storage engine underneath. S3 does not achieve 11 nines through any single trick. It's the combination: Erasure coding for efficiency, multi-Z distribution for fault isolation, checksums for integrity, and automated repair for speed. Together, they make data loss practically impossible. 11 nines is not a marketing number. It's a promise built on mathematics, distributed systems engineering, and relentless automation. Thank you for watching.